So we resume with the conics, and in conics we have circle, parabola, and hyperbola. We will postpone hyperbola and stick to parabola and circle for now. And let's say if we are to discuss a circle, then we have two situations. The first one says that the circle is somewhere in the quadrant away from the origin. Excuse me. And in this case, the coordinates of the center are uh, x minus h and y minus k, because here we have x and here we have h, and similarly here we have k and here we have y. So this is the center, and the other case is when the circle has the center on the origin. So the situation changes. In this case, see, now the center is here and the center is x, the center is origin. It's yes, the center is 0 0. Okay, so in general, if we are to discuss a circle, so we have this form which says x square plus y square is equal to r square. So x is equal to x minus h and y is equal to y minus k, as I showed here. Yes, and if the center is on the origin, then h is equal to k is equal to 0. So x is equal to x and y is equal to y. So the equation becomes x square plus y square is equal to r square. Yes, and in general, the extended version of the general form of the circle is x square plus y square plus 2gx plus 2f pi plus c is equal to 0, where center has its coordinates minus c and minus f, and the radius is g square plus f square minus c under the root. Okay, so this is the generalizations we need to know about the circle. And now we have parabola. Yes, so parabola says that there are versions. For instance, parabola says that we have a form right here on the origin, and then we have a form here which is away from the origin. Yes, the focus is not on the origin. See, the focus here is 0 0, but the focus here is on the other side. It's not 0 0. It's the focus is, well, Yes, something, but actually, if we are to approximate a point on the parabola, then basically we take the projections and we go x minus h, which is here, and then we go y minus k, which is here. K is here and y is here. K, y, and then this is y minus k here. So in this case, basically, you see the equation of parabola on x-axis is y is equal to y square is equal to 4ax, where a is the focus and focus is a, and latest rectum is 4a, and then we have the directrix also on the opposite side of the latest rectum. But what we are looking at is not this, but the general form. So you see, let's say we have this general form, capital Y square is equal to 4ax. See, so if the parabola is has its focus on the origin, then this is the form, first one. But otherwise, here's the thing, where we substitute y is equal to y minus k and x is equal to x minus h. So the situation is y minus k whole square is equal to 4a into x minus h. Yes, so y square plus k square minus 2yk is equal to 4a into x square plus h square minus 2hx. So this is the form. And some people can be comfortable writing y square minus 2yk plus k square is equal to 4a into x square minus 2hx plus h square, which clearly shows that we have sorry, there's a mistake here. So we have to make a major correction here. The problem here is that we don't have a square on the right side. So this is x minus h, and this is 4ax minus 4ah. Okay, so it's pretty simple. Let's say if we are to take y square minus 4ax, the major variables on the left side, then the situation would be 2yk goes to the other side, minus 4ah already there, minus k square. Yes, so this becomes a form where we need to know the focus and the h and k, and then we can approximate y and x. So once we are in a position to approximate x and y, we can start plotting the points on the curve of the parabola. Let's leave it on the differential equations. So the differential equations, ordinary differential equations. So for example, dy by dx is equal to y plus 1 by okay, yes, y plus 1 dy by dx. Yes, so this is a differential equation uh, as the differential of y is equal to y plus 1 into differential of x. Okay, so what we do is we collect the like terms on one side. 1 by y plus 1 dy is equal to 1 dx. Yes, and then we integrate 1 by y 1 by y plus 1 is equal to dx. So what we get is natural log of y plus 1 on left side and x on the right side. And now we need to get rid of natural log. So Euler's number comes in, and y plus 1, and this goes into the exponent of e to the power x. Yes, so, and there's one more thing. As we're integrating, so this plus c, constant of integration, and x plus c, everything goes into the exponent of the Euler's number e. So y is equal to e to the x, e to the c dot e to the x minus 1. So this is the generic solution we have for this ordinary differential equation. Yes. So we have this issue on the absolute potential. The gravitational potential, absolute potential.